Okay, hello everyone. It's 12 o'clock, so we're going to go ahead and get started. Thank you for joining us for our second webinar series on team science and engineering design research. I'm Scarlett Miller. I'm an associate professor at Penn State in engineering design, and I'm also the director of our engineering design program. And I also have another hat, which is the associate editor for the journal Mechanical Design. I focus in design education as well as design theory and methodology papers. So let me go ahead and share my screen today, and we'll get started with our exciting lineup here. Wade, can you give me a thumbs up if you can see my presentation? Perfect, thank you. Okay, great. So kind of an outline of what we're going to do today. We're going to start with just a little background on why we're focusing on team science today. So I'll give a little intro of that and an intro of the papers we're going to hear from today. Each speaker is going to have 10 minutes to present their papers, and then followed by 5 minutes of Q&A. So you should be able to see in your chat box or your options there to ask a question, or you can post it in the chat. And I'll be kind of narrating those and inviting people to ask questions within 5 minutes. At the end of it, we're going to have about 20 minutes, 15 to 20 minutes for a panel discussion on kind of some key questions on team science and how it relates to the Journal of Mechanical Design. And then following that, we're going to be having a Q&A/networking session in gather.town. I'm going to go ahead and post that link in the chat window. I'll be posting it a few times today for people to be able to access that as we proceed. It's a great opportunity for people to ask additional questions to everyone, to facilitate kind of that networking that we've really missed out over this last year, and kind of catch up with colleagues new and old. So that's kind of the rundown of the activities today. But before we get started, I think it would be remiss not to acknowledge a key member of our community that we've lost over this last year. Dr. Linda Schmidt, we lost suddenly in March of 2021. She was a vital part of the community, both the Design and Education Committee, as well as the Design Theory and Methodology Committee as well. Dr. Joshua Summers, along with others, is going to be putting together a kind of session during IDATC this year of presentations, ideas, and reflections to remember Professor Schmidt. But we wanted to formally recognize her now with a moment of silence. So you guys could all join me in a moment of silence for Linda before we get started today. Thank you all. I'll be posting in the chat here in just a minute. The Design Theory and Methodology group, as well as others, are putting together a video to kind of as a tribute for Professor Schmidt. So I'll be posting that in the chat window here in just a moment as well. So why are we talking about team science today? Well, over the last decade, there's been a steady increase in publications on engineering teams research. So this was something I put together kind of quickly through the Google Scholar database, just looking for the search term engineering teams. And you can see that we have been having a steady increase in what that term is. And as an editor, I get and see a lot of the teams papers coming into the Journal of Mechanical Design. And I'll talk about kind of that specific data too. But we've also seen an increase in the media attention around the science of teams. If you just search for that word, you'll see a plethora of things, from podcasts to webisodes to print media, really discussing what it means to be a good team and how to effectively study and draw inspiration from different teams. There's a recent article of some webisodes on wired.com on the science of teams. NASA has some key insights and information on the science of teams. And then people like the New York Times have been publishing articles on what Google has learned from its quest to build the perfect team. And so because of that, and because of that increase, it was important for us to take a step back and look at what teams mean in engineering design, and particularly as it relates to the Journal of Mechanical Design. So I pulled from, these are papers that specifically mention the keyword teams for the Journal of Mechanical Design. And you can see over the last decade, it kind of remained pretty steady in terms of teams research, but we've seen a great increase in publications and submissions around this key content within our journal. And I actually took the paper's titles in this space that had the words teams to kind of look at and try to visualize what things people were looking at and exploring as it came to that. So you can see here we see some terms that that stick out a lot. Creativity, innovation. We see things pop out like teams, education, human, simulation, and systems. And the papers that we invited to present today really kind of focus on a wide breadth of what teams mean to us as engineering researchers, and the different methodologies that we employ to study these teams. I also did a quick word cloud on the keywords. So these are the keywords, different keywords people used, and what those associated with teams in engineering design as it comes to the Journal of Mechanical Design. And the thing that's interesting to me is that we see methodologies coming out, prototyping, models. We see algorithms, systems, manufacturing. So we see both a breadth and variety in terms of the applications in the focus area of engineering teams, as well as the methodologies which we're using teams. So studying real human teams in design education versus simulating teams. And what are the implications of that, and how does that factor into kind of the papers and the next areas of research in this field? So there's kind of three key areas that I'm going to focus my specific questions on to our authors today. First is a question of what is a team in engineering design research? So I employ you all to kind of think about these as we go through it. You'll see the papers that were selected to present today view and come at teams research from a wide variety of angles. The second one, what are accepted methods for studying engineering design teams? So a lot of the papers that we'll see today, some borrow from the social sciences in terms of the way that they view and analyze teams and team dynamics. Some focus more or pull more from computer science perspective of how do we look at algorithms or other more simulated methods of studying teams. And then finally, I think, this is the Journal of Mechanical Design, second webinar series here is I wanted to focus on what are challenging to publishing engineering design teams research, kind of lessons learned from reviewer two is what we always call them in our group, the kind of critical reviewer of the papers to help people kind of get their work published and over that hurdle for our journal. So those are kind of the three key insights or three key things that we'd like to take away from today's webinar. So we have a great breadth of speakers today, starting with Dr. Kosa Goucher-Lambert from UC Berkeley. Our second speaker today is Dr. Faez Ahmed from MIT. Third is Dr. Jonathan Cagan from Carnegie Mellon. And last, but certainly not least, is Dr. Jessica Menold from Penn State University. So again, we're going to go through 10 minutes of presentations, followed by 5 minutes of Q&A from each of our speakers. And then lastly, we'll end with the Gather.town event. A quick Gather.town introduction. I'll go through here in just a minute, although I noticed today when I logged in, there is a quick tutorial now when you log in. So if anyone's unfamiliar with that database or that system, you should be able to know that. First, a couple of logistics. One is please mute your microphones. Amy is gonna help us here. Amy Susky, who's a helper for the journal, is gonna go through and help us with that. So thank you, Amy, in advance, and for all of your logistical work you've helped with before this. 10 minutes, followed by 5 minutes of Q&A. Please post a question in the chat again. I will ask that question after each of the talks. And then remember, there'll be a panel Q&A after. I'm going to post anyone who can't see or logged in after my first post. Here's the Gather.town information. This is what the entrance looks like. It's the interface is meant to kind of mimic real life interactions. So you'll get a little avatar who you can move around the space using your arrow keys. The closer you get to people, you'll be able to hear conversations just like if you were walking down a hallway. So if you want to talk to someone, you can walk up closer. There's also a separate room up at the top of the map. And that room leads you to a main area. Anything in these blue areas are private conversations, meaning you have to be on the rug in order to participate in it. And we will kind of mark the different area for each of our speakers to go to if you have follow-up questions for them. So at this point, I'm going to stop my introduction and pass it over to Dr. Goucher-Lambert from the UC Berkeley. So Kosa, I'll let you take it away from here.
All right, thank you, Scarlett. Okay, let me share my screen. Wonderful, everything looking okay? Great. All right, well, thank you, Scarlett, for that introduction, and JMD organizers for putting on this event. My name is Kosa Goucher-Lambert. I'm an assistant professor of mechanical engineering at UC Berkeley. And I'm really excited today to share some recent work from our team here on examining the decision-making strategies in human-centered design teams method selection. So seeing as though this is a webinar on teams, I would be amiss if I don't first acknowledge my own team. So this work is in collaboration with Professor Alice Agogino at UC Berkeley, Dr. Jun Kwan, previously at Minnesota and now at Samsung. And then I really want to highlight and acknowledge the first two authors on the paper. So Professor Woo-Young Kim, now at TU Delft. This work was a kind of a culmination of some of his PhD and postdoc research. And then the lead author for this paper, Dr. Vivek Rao, who's a current postdoc at UC Berkeley. So our overall goal here is to try and understand the design method selection behavior at a team level, and to do this across varying project types and durations of projects. And so we're building on here a trend of work in both industry and academia that have made design tools and methods more tangible and more accessible. So we can think of things like the IDEO method cards, the really wonderful design principle cards at SUTD and MIT. And in this work, we're leveraging the Design Exchange, which is a collaboration between Berkeley and MIT, in which we have an open source repository of design methods and case studies. So some prior work that's really relevant here has explored what methods designers are choosing. So this is some work from 6 years ago now with Mark Fuge and Alex Agogino on the design methods selection for open IDEO challenges. And so here we're building upon this to explore a little bit deeper why design teams are choosing the methods that they do, and how their decision-making strategy is changing both across the phase of the human-centered design process, as well as based on what we call the project type that they're working on. So we have three interrelated research questions. The first being, how do the prevalence of decision-making strategies used by teams differ across the phase of the design process, also based upon the project type? And then a third question, which is, what elements of the decision-making strategy drive team selection of methods? So for this study, we draw upon approximately 300 different method selections by 21 student teams. So this is 88 students at UC Berkeley who are engaged in a semester-long human-centered design course. And so here are the 5 phases of the design process that teams went through. And after each phase, they had to select 3 methods in which they wanted to utilize. So I'll just give an example of what this looks like. So in the research phase, they'll get a subset of methods to choose from that we've introduced in the course from the Design Exchange. And then we ask them to really go in depth with 3 of those. So they'll select 3 methods and then justify why they're using that method. So they have to provide responses for the 2 following questions, which is, what factors did you consider in choosing this method? And why do you think it's appropriate method for tackling the design challenge? So with those written responses that teams are providing, we then code them using a new framework that we developed called the Agent Outcome Process-Based Framework. So essentially there's 3 high-level themes that all of these responses are coded into. And this is what we're using to define what we call decision-making strategies. So in addition to these 3 high-level codes, there's also 8 subcodes that add more detail. So for example, an agent-based code might relate to an individual or a group level rationale for why that method was selected. And here's just a few examples from our data set of what this looks like. So these are 2 different outcome codes. The first is a team describing how they chose one-on-one interviews to allow them to narrow down to a target group and understand each individual on a deeper or more personal level. So we would class this as a user-based outcome code. And the one on the bottom here, we see that a team is selecting a method, tangible prototyping, so that they can interact with the physical product more effectively compared to either a sketch or a model that they might develop. And so this is a product-based outcome code. Now, in addition to these different decision-making codes, we also are classifying the type, innovation type of that the project falls within using Sestian's taxonomy. And so all of the project topics were coded as being product-focused, product service-focused, or spatio-social focused. Now, in looking at just a high level of some of our findings, we see that agent and process-based decision-making strategies are the most popular and define team method selection overall. Going into a little bit more detail, we also see that these same strategies are most common regardless of the project type that teams are working on. We also see that this trend of a preference towards agent and process-based strategies being present in all design phases except for the build phase. And in the paper, we go into a significant detail into some of the different rationales and our hypotheses on some of the findings. I just want to highlight a few more here. So one result is that we see by looking at significant differences that there's a low proportion of outcome-based strategies for spatio-social projects and during the ideate phase. And so what we conclude here is that human-centered design teams surprisingly are often not thinking about outcomes, and that this is particularly linked in the ideate phase, and that teams are struggling to conceptualize outcomes specifically for spatio-social projects. Another interesting technique that we used was this mapping of how decision-making strategies dynamically shifted and evolved based upon the phase of the design process. And what you see here is the relative and subsequent selection strategies that teams use across phases. And so one interesting trend here is this shift from agent and process-based strategies in the ideate phase to outcome-based strategies in the build phase. And again, several more examples present in the paper. Okay, so just to wrap up with some high-level findings. So we see that decision-making strategy differs across phase and innovation type, with a particular lack of outcome-based strategies that teams are using. So we conclude that while outcome-based strategies are underrepresented throughout our data set, they're especially absent from the build phase and from spatio-social projects. We also conclude that our findings point to opportunities in which we can better guide design teams' success and help teams select methods that might address shortcomings in their approach. So one example here is that we find teams are very inconsistent in mapping the design process onto outcome strategies related to users, products, markets, and technologies. So future design tools can help augment and shift teams in their approach and their rationale and thinking. And then my last slide, just connecting back to our theme today of team science and engineering design. I think there's a lot of challenges and opportunities, and I know one of our talks today is really looking at this idea of, the individual component as a part of a team. So in this work, we're studying team level behavior, and I still believe that linking individual contributions within a team level context is quite challenging and in an area for future investigation. I also believe that there's unique opportunities for studying innovation processes over what I'd call longer periods of time. So here we focus on a semester long design challenge with students. And I know in our community, there's a prevalence of really, well done and thoughtful controlled experiments over short periods of time. In our study, we find that there's significant differences on the phase of the design process. And so this indicates that the timing and length of time that we're studying for these types of studies has a significant impact on our results. And the last is that intelligent tools that we're developing as a community need to consider not only the project type or topic and the design phase, but also the decision-making strategy that a team is engaged in, because that has a significant impact on their process-based decisions. So with that, I'd like to encourage you to have a look at our manuscript in JMD. And we'd be delighted to answer questions now or offline if you want to reach out to me or any one of the authorship team. Thanks so much.
All right, thank you so much, Kosa. Great presentation, really enjoyed it. So thanks for sharing with us. If you have any questions, please feel free to post them in the chat. Otherwise, I'm going to kick it off. So I have a few questions I've noted here. So I think, and some of this comes from my own experiences publishing on teams. So I just want to kind of ask you your input on some stuff. The first one is, how many teams is enough teams? So you had, 89 students, I think like 22 teams, something like that. How do you know when you've had enough, and how does it affect the ability to publish on teams?
Great question. I think the answer to that is it's never enough, right? We always want more teams. I think in our sense, this is, we're conducting this type of work over like many, many semesters and with, really hundreds of students. So this was a relatively small sample, I'd say, for some of the work that we're doing. And we're fortunate to be at a large public institution, have access to a lot of students and a lot of teams that we can study. So I don't think that there's a right number. It really depends on the research question that you're asking. For a lot of our work, I would say at least kind of like 15 to 20 teams is probably appropriate in the minimum bar, but we usually shoot for higher than that.
Great. And then, you talked about some qualitative coding and using that to extrapolate. And I think I would argue that, 22 teams sometimes will be like, that's not enough, but the depth of the data and the analysis you do is what made that like a valuable and a rigorous study. So can you talk about some of the challenges with qualitative research in teams and justifying the rigor of that?
Yeah, absolutely. So I think that the, this AOP, Agent Outcome Process framework that we developed is one of the major contributions from this work. And, of course, a lot of people in our community are aware it's a great challenge, right, to do this qualitative based research. And, here that framework, that's just something where multiple members of our team and people who are not even on the authorship team, but researchers here, have coded the data. We're using different inter-rater reliability measures to confirm that, everyone is coding the data in the same way. And so, yes, I think that that adds a level of depth and rigor. But I think that's another challenge for our field, is how we blend, objective and subjective techniques and make sure that our results are reproducible and real.
Awesome. Okay, one last question from Allison. So she says, great presentation, Kosa. How do you think the team influences these decisions about methods? Would it be consensus driven? Would one person dominate? Or do you have any evidence to know? How would the team factor into this?
Great question. Thank you, Allison. So I have to punt some of this because it's our ongoing work. And I know that John Cagan has a presentation today about individual contributions. But ultimately, I think that there's a variety of factors here in terms of our data set. And that's why we're so interested in this question. And I mentioned at the end, is it really consensus driven? We'd like to think so, but I think a lot of the times, especially in this student context, we have individuals who are driving. Maybe they're driving because of, they might have a little bit more domain expertise or knowledge, or maybe they have a more dominant personality. So that's something that we're really digging into right now. And I don't have a clear and clean answer for it, but it's a great question.
Well, I think that'll set us up nicely for our panel discussion later this afternoon, morning, evening, depending on where people are. So thank you, Kosa, much appreciated. And
Great,
we'll hear more from you a little bit later. Our second presentation today is Dr. Faez Ahmed from MIT. So Faez, do you want to go ahead and share your screen and take it from here?
Right. Thanks, Scarlett. And I hope everyone can see the screen. Great. So hi, everyone. I'm Faez Ahmed. I lead the Decode lab at Mechanical Engineering at MIT. And today I'm going to talk about the topic of forming diverse teams. And this work has been done in collaboration with Dr. John Dickerson and Dr. Mark Faez at University of Maryland. So the question which we'll talk about today is, how do you form diverse teams? And what I'll do is I'll first break it down into showing how this big question of forming diverse teams can be reduced to certain computational formats, and then how we address this problem. So the way we'll start is first we'll talk about how team formation is basically a matching problem. Then we'll go into some past work just to provide the background to people on when you have a collection of people and a collection of teams and you want to match those people to teams, how do you do that using something called offline diverse matching? And then move on to this current work, which is what happens when people are arriving one at a time, which is sequential arrival, or something called online diverse matching. Great. So just for people who are new to the term matching, matching is something which we see all around us. Every time you go and take an Uber or a Lyft, the company matches you to a driver. When patients are going, when there is a requirement for kidneys, they match kidneys to patients and so on. So matching is everywhere around us. When we click to Facebook, Google, they match us to advertisements. Matching can also be seen as something where we want to match people to teams. So matching, the team formation problem can be seen as a matching problem within when you're looking at the computational aspects of it. And just to take a toy example, we'll take the example of this problem, which we are generally, all researchers are aware of, where you have a set of papers on the right-hand side. These are 4 papers, and you have 4 reviewers. The papers are broadly, 2 of those are on robotics and 2 of them are on controls. And there are reviewers are also their expertise. 2 of them are in robotics and then controls. And what we want is to find 2 reviewers for each of these papers. And each of these reviewers have certain requirements that I'll not review more than 2 papers or so on. Now, this problem, as you can see, can be seen as a matching problem. And every node on the right-hand side can be connected to the nodes on the left-hand side. And again, this is not necessarily a completed graph. Now, when we look at these reviewers and papers, you can look at essentially how good a reviewer is for a certain particular paper. And this, again, is in itself a big research question on how to find these numbers. But for the sake of today's talk, we will assume that we know this. So we know that robotics reviewer 1, who is quite relevant for this specific paper. So they get a score of 0.9. And they do not get a very high score for this paper on controls, because that's not related to their research topic. Now, let's say we have this information. So we have the edge weights within this graph. So for every edge, we know how good the match will be. Now, our goal is to find a good team. So essentially, how do we form teams such that every review paper gets the appropriate reviewers? Now, this is, again, a classical matching problem. There has been algorithms since 1990s, where they have provided methods to solve this in polynomial time. So even when you have thousands and thousands of papers and reviewers, you can do this very quickly. Great. So we would think that this problem is solved and we can just find the best papers and reviewers for this problem. However, there are 2 big issues which classical work has not looked into. And the first thing is the idea of diminishing marginal utility, which says that once you have 3 reviewers and you add a new reviewer, the value provided by new reviewer is less if there are already existing many reviewers of the same type. So if there are 3 robotics people, the 4th robotics person, their review will not talk about many new things, versus if there is a team of 2 people. And this quality called diminishing marginal utility is captured by certain functions called submodular functions. I will talk about how we leverage this mathematical property of submodular functions later in the talk. The second thing which we really care about is diversity. So when you have 3 reviewers who are providing one perspective, you want certain new perspective to look at to join the team. And someone who is coming from outside this group of robotics can provide new perspective. And when I say that diversity is good for the team, it's not just it's not just for paper reviewing. In fact, there are very large scale studies. For example, this study by McKinsey and Company, which looked at thousands of companies across different continents, they found that teams, companies which had gender diversity were 15% more likely to have higher financial returns. And similarly for racial and ethnic diversity. So there is a clear demonstration that diversity is good. The question we will try to answer is, how do you form these diverse teams? And ideally what we want is an algorithm which can, given this match, it can find reviewers or basically teams which are diverse. And to do that, we first start with defining a submodular function. And again, I'll not go into the details of this function, but the key quality to know is that this function can capture the 2 properties which we talked about before. So the 2 shortcomings, one is submodularity, that when a new person adds in the same team, they have less return, as well as the second thing, when it's a diverse team, this will give you a higher score. So if we maximize this function, we should be able to get a more diverse team for any given matching. But before we talk about how we will maximize this function and how difficult it is, an important concept to look at is something called price of diversity, which we propose. And this is quite important to understand because nothing comes for free. So let's say I have this robotics paper and I have 2 reviewers with expertise 0.9 and 0.8. If I replace this reviewer with someone who is more diverse, so they bring in a new perspective, it is possible that their expertise is less. So we lose some utility, and price of diversity basically captures what percentage of utility can we lose. And or in this paper's case, which I'll talk about, how much additional people we have to interview just to get a diverse team. And it's quite important to think about in terms of making decisions within a given budget. Now, with all this, we would think that this problem can be solved quite easily, maybe manually, when you have a certain number of people and you want to, let's say you have 100 people and you want to put them into 20 teams, and each team requires 4 people. The color of the dot shows that what their maybe country of origin is. Now, as you can see, if this is a combinatorial problem with trillions and trillions of solutions, and it is not easily possible to put these people into the buckets which are each team. And when we solve this problem, it gets more complicated because it's not that each bucket has just one attribute. It can be gender, race, educational qualification, and you want diversity with all of them. But also each team can have different demands. So you can have 2 people required in this team and 4 people required in this team. So manually doing this is impossible, even for very simple cases. So to solve these problems, we first started back in 2017, and we proposed an optimization approach. And without going into the details, the key idea was that we found that we can get large gains in diversity by losing very less utility. So we lose only 6% utility for some paper reviewer matching problems, so when we gain 328% diversity. So this was a promising result. And then we extended this work with using certain graph-based approaches. And the key thing with these graph-based approaches was that we could model multiple attributes. So you can maximize diversity with respect to gender and country and so on. Again, this problem is NP hard. So it's this is an unsolved, it's a very difficult problem to solve. And we provided the first pseudo polynomial time algorithm, which can guarantee that we reach the optimal solution. Now, all of this was great. Like, we can solve this problem given any large graph, even thousands of nodes, we can come up with a solution in a reasonable amount of time. But this paper, which I'm going to talk about, is for an even difficult problem, which is what happens when people arrive sequentially. So people arrive one at a time. And what we did was we started looking into some existing literature, and we found that this problem can be seen as something called monotone submodular maximization with knapsack constraints. So again, I talked about that submodular function. You want to maximize that function with certain constraints, where every person has certain constraints on how many tasks they can do. Teams have the constraints on how many people they want to hire and so on. So we took this algorithm, and from an existing algorithm, we found there were certain shortcomings. So it was not applicable to team formation because it could not cater to certain demands of the functions. We looked at certain tricks, including how we can modify this by bringing in multiple edges. We used a concave function and so on. The details are in the paper, but I'll just talk about the key outcome was that if we use this algorithm for making teams, what we guarantee is that the team which we have formed from this algorithm is within a certain ratio of the optimal solution. And we have the proof to show that. And not only that, it is better than all existing algorithms in the literature. So it can guarantee that we can find better diverse teams than existing methods in literature. So what does it look like? So just to give you a demo, what we assume is that there are 4 teams. The first team requires 2 people, 3 people, 2 and 2 people, and 1 person comes at a time. So we do not know which people will come up. Every time a person comes, we interview them. There is a cost associated with interview, and we accept them or reject them. So the first person comes and they get hired by these 2 teams. The second green person is good for all teams, so they get hired by all the 4 teams. The third person comes, but because they're not adding to diversity, they will be rejected. They go here. The algorithm basically looks at a cutoff of marginal gain you provide to the teams. Similarly, the fourth person comes and they're only good for the first and the third team. And they will still be rejected because there are already similar people. The next person is hired, and this person, although they add a lot to the diversity, they do not add to the utility. So they are not a good fit for the teams. So the algorithm even looks at these problems. And finally, what we see is that it takes 7 interviews, it rejects 3 people, and it is able to form a diverse set of teams by looking at only 1 attribute. Now, obviously, this was a simulated example just to show you how the algorithm works. What we did was we conducted Amazon TURK experiments where online workers would come in and interview. Our algorithm will look at them and interview them, and then essentially either pass them on to a simple task of engineering design, or they would be rejected. And what we found was that for one specific case where you can see on the top the distribution we saw, it had to interview 18 people to just get three hires. And this is the idea of price of diversity. And we also looked at a lot of different combinations for every possible attribute. So just the key idea was that once you look at this price of diversity, you can think of what your task is and how important your task is for this specific application. So if example, you have to write a review for a movie, then maybe you do not want political diversity and you do not want to spend 4 times the budget. With that, I would like to just wrap up. There are multiple broader applications around, including team formation, as well as other resource allocation problems. And you can look at the relevant publications. Thank you.
Awesome. Thank you so much, Faez. Great presentation. So quick question for you in the chat here from Samuel Denard. Why is greater diversity associated with lesser competence? Isn't that a symmetrical relationship?
Great. So it's not necessary that it is lesser competence. The idea is that we measure the difference. So it is possible that in certain scenarios, the more diverse team is going to be better. However, then the traditional approach will also work.
And then I have a quick follow-up for you, and then I'll ask you some more in our panel. So what type of diversity does this work for, right? So, you know, and how much diversity is too much diversity? So you kind of hinted at it in your classification of diversity, but what
Yeah, so for the first question, the way this diversity works is anything which you can divide into groups. So it can be gender, race, it can be educational qualification, expertise. The idea is that people have certain labels associated and we can maximize diversity for them. And then for the second part, there are certain parameters where you can balance that one type of diversity versus other. So we can basically put those parameters value to 0 and then just get the traditional matching. Versus we can just have, now the question comes to what's the trade-off and what's the right answer? And this is an open question. I think we do not know. And it also depends on the application. So for some applications, you would want a very diverse teams. But if you are designing a rocket and you do not want maybe diversity for educational qualification, you do not want 2-year-olds to work on it, for example. So it depends on the application.
Awesome. Well, thank you so much for that great presentation. Our third speaker today is Dr. Jonathan Cagan from Carnegie Mellon University. He's going to be talking with us about how you're only as strong as your strongest link, and it'll be kind of a nice crossover between some of the stuff we've heard from Kosa and Faez this morning. So John, take it away.
Thank you, Scarlett, and thank you for the invitation to be here. And also thank you, Wei, for creating these webinars for this community. I think this is great for all of us. And I'm really pleased to be able to present this work today. The work really is driven by Ethan Brownell, who's a PhD student working with myself, and Ken Pitofsky, who's a cognitive scientist at Carnegie Mellon as well. And we're going to talk about the impact of the individual team member proficiency and configuration design. And hopefully I can, here we go. So, engineering team design is a human activity. It's typically done in teams. It's the focus of what we're talking about today. But the motivation for this particular work is what role does the proficiency of the individual play in affecting overall team output? So this has been studied at the overall team level, the average team level in design, but not the individual's impact on the team itself. So first, we're going to talk a little bit about football. And for those of you who might not be in the US, this is American football. Tom Brady took over as the starting quarterback for the New England Patriots. And that year he took over, they won their first Super Bowl. And they won 6 Super Bowls with him as leading the team. Just for comparison, the Pittsburgh Steelers have also won 6 Super Bowls, but with multiple quarterbacks. But then last year, he moved to the Buccaneers. And he took that team from a losing season to winning the Super Bowl. So we see him here, and as a Pittsburgh Steeler fan, of course, we don't want to leave you thinking about him as a Patriot. But with that, it leads us to think now about design teams. And there's 2 different types of teams. There's the average contribution model, where all members affect the team equally. And that's typically how we've been looking at teams in most of the research that we've done so far. But there's also something called the relative contribution model, where the overall team performance depends more on the characteristics of certain members. And so this is actually leading to the focus of today's talk, because if you think about relative contribution, there's different ways you can, different categories that Steiner came up with. One is the disjunctive tasks. So here the team can only accept one individual contribution, and that's the best member who's the most influential. Or there's conjunctive tasks, which is the opposite, where the minimum effort is the criteria for success. So then the worst member is the most influential. And then there's discretionary tasks. Here, the team can combine different contributions from different individuals in any manner they wish, and that sort of leads to the choices throughout the task process. And that's the result of what we're going to focus on today, the result we see in football, but it's also what happens in team-based design, where these are really discretionary tasks. There's multiple people that are contributing, and together something emerges, some solution emerges. So the goal of this particular work was to examine whether the team with an enhanced most proficient member or the team with an enhanced least proficient member is most likely to succeed. Given a team, should you improve the best member or should you improve the worst performing member to make the team as a whole perform better? So proficiency here is an individual's ability to solve the problem at hand. And a quote that we like, Ethan particularly likes, from Kozlowski and Bell: teams do not behave, individuals do, but they do so in ways that create team level phenomena. So how do these individuals affect the team performance? So to do this, we had a behavioral study where we had individuals solving a configuration design problem. In particular, it was a truss design problem. And we had an interface that they could work with to design trusses for different situations with loads and support points, where they could add truss members, remove them, change their sizes, add nodes, move them around. And it's basically, and although most of us as mechanical engineers know how to design trusses, it's a very hard problem. And what you see on the right are 3 different snapshots. And these snapshots are the best designs so far from the different team members. You have 3 team members, yourself and 2 others. And so we're capturing the best designs. And so you as a participant, your team is trying to create the best design. So you can look at these and say, wow, team member 1 over there has a much better design than me. I'm going to take their design and start working on it from there. You can do that anytime throughout, but at certain points along the way, it's required that you take a look and select one of those 3 designs. It may be your own because you want to continue working on it. So the way this is set up is, first we have a tutorial for the individuals, and then we test their proficiency by giving them a series of truss design problems. And we see how well they perform, and then we can rank them real time, essentially, of the best performers, the worst performers, and everyone in between. And then we can create some teams. Our problem's a little bit easier than the one we just saw with Faez presented, but here what we're talking about is taking teams where 1/3 of the teams we took one of the best members, 1/3 of the teams we took one of the worst performing members, and then for the teams in between and all the other members, we basically selected randomly from that middle set. So teams of 3, 1/3 of them had a best performing member, 1/3 of them had a worst performing member. And then we actually had 2 design sessions, so we were able to get 2 sets of data. And then we regressed the proficiency of the team member based on how well their team did. And what you can see here is the green is the most proficient members, yellow, middle, and the red least. And you see consistently, so these are 3 different timestamps along the way where we wanted to get to a point where there was a good performing design. And we looked at halfway through and 3/4 of the way to get there and how long it took to get to those different points. And lower in here is better. So what we see is consistently the most proficient member has a consistent positive effect throughout the entire design session. The middle performers are pretty much in the middle, and the red, the least, are all over the board. So it isn't to say that at one time there wasn't a good or bad outcome, but in general, there's no consistency on them having a positive effect. But the highest proficiency member, we see that. So this is an indication that the most proficient member has a consistent positive impact. And now we want to try to understand that a little bit deeper. And so we looked at behavioral analysis using hidden Markov models. Hidden Markov models look probabilistically at what the next move will be given the current move based on the data. And what's hidden in that we don't necessarily know what the breakdown of these different potential moves are going to be. We want to see what combinations come out. And it turns out, again, all those different moves that I told you we can make from topology to sizing to shape. And what we find out is in the hidden Markov model, 4 different groupings is the best for the performance of the model. And we can realize that in these groupings, they're from build topology to find sizing. What we did is over this 10-minute sessions, we divided it into quartiles, and we looked at the different behaviors for the different high proficiency and low proficiency members. And what we see is anything that's colored is significant, and the green is going to be the higher performing, or the higher number, I should say, and pink is the lower. And what's very interesting, if you look at the first quartile, is something that we've actually seen on the average team behavior as well, where different studies have shown that better teams, the members do explore, but then they quickly kind of settle and they're really searching for a best design, whereas worst performing teams tend to keep exploring the space. And we see the same thing on the individual level, where the high performing teams, proficiency teams, they do build their topologies, but then they start spending a lot of time looking at fine tuning, fine sizing, whereas the low proficiency members spend most of their time just building topologies and exploring the space. If we look at the last quartile, we see something a little bit different. They're not exploring the topology as far, but we do see as the high proficiency members are spending much more time fine-tuning their design, whereas the lower proficiency are still exploring the shape in more broad sizing. So it's this phenomenon of searching, but then finding a sort of a simpler design to key in on. And if we look at what's going on here and we take a look at each team on what the highest performing proficiency and the lower proficiency members are doing, and we map out how many of them are changing the number of members in the trust and how many of them are changing the number of nodes, the blue is the most proficient members and the pink is the least proficient. And we see that phenomenon where everybody's exploring, but then the most proficient members settle into a design that they're trying to refine, whereas the most proficient members are still exploring the space. But what we find out is that these most proficient members are sharing designs from the others, and they're starting to converge toward the most proficient members. Now, these vertical lines are when we make them explore the other designs on their team and choose one, but they do it naturally as well. As a matter of fact, you can see that right before that first required point of sharing designs and choosing, they're starting to pull down, which means they're actually on their own looking at other designs and they're accommodating them or accepting them. So whose design is it that they're working on? Is it that the best members are just creating the best designs and that's it? It actually is not the case. So after that first interaction, the least proficient members topology is being worked on by about 30% of the teams. And the most proficient members topology is about 74%. These numbers don't add up to 100, by the way, because there's multiple people on teams. So, but within the teams. So certainly the proficient members topology is being worked on quite a bit. The most proficient member creates the original topology for the team's best design more than any other team. But the creator of that initial topology for the final design is not always the same member that uses that topology. So a most proficient member is generating topologies potentially, and others are taking them and they're building on them, and that might lead to the best final design. And as a matter of fact, only two of 23 teams had the same member held the best score during the entire design session. So what we're seeing is this most proficient member is quite influential in terms of the designs that they're creating, but it isn't that they're just creating the design themselves. So we learned that in configuration design teams, they're strong link teams. The teams with the strongest member usually performs the best. With proficient designers, they spend less time building topologies and build simpler trusses, and other designers tend to adopt these simpler designs. And to create better configuration design teams, one should either select a high-performing member or invest in training of that member. That isn't to say we shouldn't raise the common level of the entire team, but if you have limited resources, you're better off improving the higher performing member. And with that, I'll take some questions. Thank you.
Thank you, John. What a great talk. You really enjoyed it. I'll kick it off here. So first off, you focused on the strongest member rather than the weakest member here. So do you want to talk about some of the rationale behind that when you were looking at the team?
Well, I know that we focused on the stronger. We looked at the stronger and the weaker, and we wanted to see who had the biggest effect in terms of a relative change. It turns out that the highest member, highest proficient member is the one that has the highest impact on the team.
Great, thank you. And then the other question I had for you is, I think one of the challenges to studying design teams is the task you're given, and then the generalizability of those findings beyond that task. So you guys chose the trust design. So do you want to talk about a little bit about how you picked that, and then how you guys kind of scope the generalizability of your findings in general in teams research?
Yeah, great question. Well, I mean, we had prior work. Chris McComb had done some really nice work earlier on, building a trust design problem that we were able to leverage and build upon. We picked that because it really is a simple problem to think about, but a very complex problem to solve. And it made sense to build on that. When your question of generalizability leads to your second reviewer comment that you started with, and that good reviewers push and say, how general can you claim? We do believe that this is a general finding across many design problems and certainly configuration problems, but clearly we've only shown so far that to be true within this trust problem. And where, some of the work that Ethan's been doing from here is to really look at how you can create computational models that emulate humans so that we can start to explore large sets of problems and see how general this becomes. And that will be future work that we'll be publishing.
So a question in the chat from Mark Fuge, it's similar to mine, so I'm going to try to ask in a slightly different way. It's on the same line as tasks here. So do you think things like groupthink or fixation or suboptimal solutions play into your work that you're doing here on teams in these environments? And how does that relate to the task that's chosen?
So groupthink, how does
fixation,
that? Well, okay.
Fixation.
Yeah. Well, it's interesting. It's a great question. And certainly there are, we've done a lot of work at how you break fixation in the past and looked at things like that. But here, what's interesting is that the way these teams are communicating is through that interface. So they're not having conversations per se. Now, the prior work has shown certainly that there is the issue of fixation. People tend to like their own designs, et cetera, but we are seeing that there is this exchange going on. And so people aren't being fixated on their own design. Maybe it's partially because of the interface or the way the teams were allowed to communicate, but that wasn't a phenomenon that I think we've seen.
Perfect, thanks so much. All right, John, thank you so much for your presentation. We have some other questions we'll follow back with during the final panel today. Our last speaker today is Dr. Jessica Menold. She's going to be talking about the link between tangible and intangible costs of prototyping and how it relates to teams. So Jess, if you want to take it away from here.
Sure. So I'm going to assume you guys can see my screen. You're all good to go with that. But yeah, hi everybody. My name is Jessica Menold. I'm an assistant professor in mechanical engineering and engineering design at Penn State. I'm also the director of Thread Lab. And today I'm going to be reviewing a paper by myself and one of my amazing graduate students, Jacob Nelson, titled Between Worlds, Exploring the Links Between the Tangible and Intangible Costs of Prototypes. So I want to start by just kind of some background, right? So prototyping is a fundamental part of the design process. And we know from prior work that prototypes can help designers to generate new ideas, test assumptions, and inform design decision-making. And the act of constructing and evaluating a prototype specifically helps designers identify unknowns and communicate new insights to both external and internal audiences. And although prototypes are really critical to design, they also represent a significant investment in terms of resources, in terms of money, in terms of time. And so prototyping thus really represents a significant financial risk for design teams. And if the knowledge generated during prototyping efforts does not justify this investment, we argue that prototyping efforts are likely wasted. And so in a lot of our work in my lab, we really conceptualize the value of prototypes or prototyping efforts as this relationship between the value of knowledge gained from the prototype versus the value of those resources the team has invested. But one of the challenges with prototyping is that it's inherently difficult to quantify the value of knowledge developed during the design process, particularly with respect to design outcomes. It's really challenging for designers to explicitly identify emergent knowledge outside of those larger aha moments. But often in design, much of the knowledge that's gained during design tasks is really internalized and unconsciously added to the designer's mental model of the design space. So our group really wanted to understand, how do we identify knowledge or quantify the value of this knowledge, particularly at the team level? So traditionally, prototyping has been studied at the individual level, but we know that design is a team sport, and we wanted to understand the relationship between the tangible costs of prototypes and the intangible outcomes at the team level. And prototyping actually is a great kind of link to what John was talking about earlier, right? It's a collection of individual actions, but it does have a larger team kind of outcome and effect. So our work was really motivated by three key research questions. The first one was, what is the relationship between time, cost invested in the prototype and the perceived value of the prototype with respect to the design team? How do all of these variables relate to design performance and design knowledge, again, at the team level? And can we find unique strategies or archetypes of prototyping behaviors that really emerge across teams? So as I mentioned earlier, it's inherently difficult to capture and quantify the value of design tasks, particularly in authentic or semi-authentic design settings. So what my lab did was we made the Archie system, which is shown in your left here, which is a real-time data collection unit that really quickly captures 360-degree images of prototypes, as well as design teams' perceptions of prototypes via a survey. And our survey specifically asked designers what the purpose of the prototype was, what the outcome of prototyping was, what they learned, right? If their requirement set was updated, and again, the time and cost of those efforts. So for the current study, we collected about data from about 69 total design teams in a junior level mechanical engineering design course over 2 different semesters. And we analyzed this data with respect to the research questions, and what we found really surprised us. So our first finding was very interesting, which was that the time or money invested was actually not at all related to the design performance or to the team's perceived value of that design. So designers didn't, even though they might have spent a lot of money or invested a lot of time, the team didn't necessarily link that, right? That there was no correlation between that and whether they viewed their prototyping effort as useful to the ultimate design direction or design trajectory. We also found that high-performing teams generally valued earlier, lower fidelity prototypes much more than higher fidelity or later stage models. So what we found was that high-performing teams reported using their prototypes to explore the solution space and identify unknown requirements earlier in the design process. So what we hypothesized was happening is that these higher-performing teams utilize prototypes to really rapidly converge onto a single design solution. And this gave these teams more time to optimize the performance during the testing and refinement stages of their design. So comparatively, lower performing teams reported using later stage prototypes to explore the design space more frequently, indicating that these teams may have converged to a design solution far too late in the design process, really limiting their ability to fine-tune final systems. Finally, we used K-means cluster analysis to identify kind of emergent archetypes of prototyping behavior. And we found 3 unique clusters that kind of came out of this analysis. So first of all, teams in cluster 1, we found were generally outperformed teams in clusters 2 and 3. They viewed prototyping as a way to learn more about the design space. So these teams tended to value earlier prototypes. They spent much more time earlier on kind of redefining the problem space, discovering unknown requirements, updating that requirement set. But then again, right, they converged rather quickly. And we also found, quite interestingly, that these teams tended to spend the fewest amount of resources on prototyping efforts. Comparatively, we have cluster 2. This was kind of like our chaos cluster. In general, teams in cluster 2 tended to lack an intention or a strategy at the outset of prototyping. Interestingly, these teams reported spending the most resources on prototyping efforts, but did not view these efforts as valuable. And this really aligns with a lot of prior work in prototyping literature, which has demonstrated the ability of intentional prototyping strategies or best practices to decrease the time and cost of prototyping efforts. But what I'll highlight is that a lot of that past work has been done at the individual level. So it's interesting to see that this finding extends to teams as well. So our next cluster, cluster 3, tended to view prototypes kind of very narrowly. So our teams in cluster 3 basically exclusively used prototypes as tools to evaluate the technical feasibility or the technical goodness of their designs. So they did not use prototypes to explore the solution space. They didn't use them as communication tools. Instead, they again held this really narrow view of the utility of prototypes. And this aligns with prior work by Shanna Daly at the University of Michigan, who's demonstrated that novice designers tend to underutilize prototypes during design processes if we compare them to more professional or experienced designers who use prototypes more broadly throughout the design process. So there's a lot more kind of details and interesting findings in the paper and nuances there, but I kind of wanted to review 2 larger findings and takeaways. And the first interesting major takeaway is that in general, there were very few relationships identified between tangible costs, intangible outcomes, and design performance. And this, again, this is interesting because, right, we would have assumed that maybe due to the sunk cost effect, teams would have valued prototypes they spent more money and time on, but that really wasn't what we found. And in general, there was no link between more time or money invested and higher performing final designs. So very interesting. Additionally, we found these emergent archetypes of prototyping behaviors that really were differentiated by prototyping intention before they actually began prototyping, as well as their prototyping outcomes. So whether they revised their solution set, whether they uncovered an emergent design need, all of these things kind of helped us to differentiate these different types of clusters within prototyping behavior. And linking it back to this panel more broadly, I really found that through this work, it really highlights the difficulty that's associated with capturing and quantifying the value of design activities more broadly in design teams with respect to long-term design outcomes. So this study took place again over 2 different semesters, and we kind of had to create a total unique data collection system to really ensure we were getting data throughout. I think it just kind of highlights how challenging it is to really start to quantify smaller micro level or individual design decisions that have a team level outcome or effect. So in our future work, we're really focused on kind of unraveling these relationships in greater depth so we can begin to understand more clearly the connections between prototypes, design decisions, and design outcomes at the team level. So thank you guys so much. Happy to take some questions.
Awesome. Thank you so much, Jess. It was a great presentation. So a theme we've heard throughout several of the presentations today is using students in design research, right? So my question for you, and I'll maybe open this up to the panel when we get to the panel discussion, but what have you found in terms of the generalizability of findings with students and as they relate to other areas? And then what challenges have you had with that in terms of review or 2 for papers?
So I think in general, right, there's always some pushback when you're using students as your population, and it is certainly an ongoing challenge for our community to ensure that we are using practitioner populations. But even some of your own work, Scarlett, has kind of shown that similar trends in students can be found in practitioner populations. And I think what's key is that ensuring students are similarly motivated to complete or to work on the design as a team. It's a semi-authentic setting, right? So it's not necessarily a fully controlled environment. All of those things kind of help the generalizability of your findings. And in the current work, we were able to link some of our findings, for example, with cluster 3 is typical of novice engineers. And however, some of our other findings, right, is not necessarily a trait purely of novice designers. And I think that's where you can start to just be very clear with the generalizability of findings.
Thank you. And then there's a question in the chat for you. It says, this is really cool. Can you talk more about how you quantify design outcomes? And I think that's a really important question, and how you quantify and kind of discuss that in your work.
Yeah, so it is really challenging, and it's something that we're still working on. However, the paper kind of gives more details on what exactly was in the survey and how we went about quantifying things. I can give you a very quick example. So we asked students throughout the time here to list their requirement set. And basically what we looked at was the similarity of the requirement set with respect to each time point that we collected it, to try and understand how requirements were being updated and how that may be linked to the prototype and different types of emergent knowledge that was coming out of the prototype. So it was a combination of some quantitative methods to, again, you can find the details of which are in the paper, in addition to some qualitative abductive coding leveraging literature from our current practice.
Awesome. And then one more question. I'll save my question for the panel. So I'm going to go with the one that's from Talon in the chat here. Great talk, Jess. I wonder if you established a baseline for design teams, so before conducting the experiment, in terms of how they should be using these prototypes in terms of informing their design. Also, did you consider the impact of team characteristics in terms of background or diversity in terms of utilizing the prototypes?
Yeah, so to answer the first part of that question, everyone in this junior level class, right, has received the same first year design course and was receiving the same junior level mechanical engineering design course. So that was kind of our baseline, but we didn't want to bias them in any way by saying this is how you use prototypes or this is what you should be using prototypes. So they all received kind of a review of prototyping practices according to Ulrich and Eppinger's Product Development and Design, which is the textbook we use here at Penn State, but we tried not to overly bias them in any one way or another. And then to answer your second question, which was, I believe, did you consider the impact of team characteristics in terms of background? So not in this particular study, we did not look at that because they were all mechanical engineering designers. And we had a pretty, not necessarily the most diverse population of students for this particular study. However, in some of my other work, we did look at the disciplinary diversity of teams, interdisciplinary diversity, and we looked at kind of how that affected industry sponsors' ratings of team effectiveness. And so I can point you to that paper in GatherTown if you're interested.
Awesome. Well, thank you so much. I'm going to invite at this time the rest of our presenters today to turn on their cameras. I have a couple of questions I have jotted down here for you that have come into me either privately or just questions we didn't have a time to get at that I'll open up here. I think we will just, maybe I'll have you guys raise your hands if you want to answer your question, the question that's if I don't specifically direct it at you. And then if you have a question from the audience, I just ask that you use the raise hand feature and I'll ask you as well to unmute yourself and ask it yourself. So this was a great general question that I got for the panel today. So they said, I have a general question for all of the speakers. Given that team science has been studied by other disciplines, so network science, computational social science, management science, social science in general, how is the engineering design community going to add value to that already growing area of research? So I showed, at the beginning today, how many papers are published in this space, just with engineering design specifically. So are we looking at team problems that are specific to engineering design? If so, what characteristics of those make them different than general results in team science? In the work of people like Goucher Contractor, who's actually here today, it would be great to have a discussion on this. So I want to open it up again. Just raise your hand, the speakers, and I'll direct it to you. But does someone want to get started?
Probably none of us want to get started, but I'll
John, you're unmuted, so we'll go with you.
But I'll jump in. I think that it's interesting. The question was, what can we do if all these other people are working on it? But the question is also, how can we contribute to other insights? So, we've looked certainly at in different ways at some of the other literatures, and I've certainly worked with people in organizational behavior and other areas as well. And certainly there's a lot we can borrow from there, but design problems are very tough problems. They're some people say wicked problems. They're very complex. We're looking for real creative solutions. They're dynamic, et cetera. And so there are certainly attributes that I won't say we have and nobody else does, but that aren't necessarily always looked at in terms of some of the other research. So I think that these are fields that have not found the answer yet. People have made contributions, and we need to be very aware of some of the fantastic work from other disciplines. But that isn't to say that there aren't ways that we need to make contributions or can make contributions, should make contributions that are really relevant to some of the problems that we solve and actually share back as well.
So I'll just kind of add to John's note that I think that there's a lot of characteristics about engineering design problems that kind of distinguish the problems themselves and the individuals solving them as a unique population. For example, right, and I'm thinking purely of prototyping, but a lot of engineering design problems involved with cognitive processes, but also psychomotor processes, right? So there's something tangible, there's something physical, there's a spatial reasoning element to it. And so I think I agree with John, right? A lot of that requires a collaboration between the fields. I don't think it's going to be successful or we're going to answer a lot of problems by remaining in silos. So, I think this collaboration is key.
Okay, I have a kind of a follow-up. Again, this is open to anyone. We talked a little bit earlier about how the design task can impact perhaps some of the findings that we have, right? So a follow-up question to that is how do we promote replications of studies in the field of engineering design? So Faez, do you want to start tackling that first? I'm going to go with whoever's unmuted. So unmuted means you're volunteering.
Sure. I think in terms of replication, I'm a big fan of having certain baseline tasks, and essentially any new method which we come up with, we can have those baseline tasks and perform them and essentially compare them. The same way in machine learning literature, a lot of standardization happened because they were like these tasks which everyone would perform, and then they would come up with their own thing too. So that's one way I think we can ensure that the results are comparable with different approaches.
I'll just add, I think the other thing we should be doing is sharing both our problems and our data. We've published some of our study results, especially stuff I've done with Chris. We've published in Data in Brief, and others, we may try to make things available. So I think that would be another way for people to be able to see problems that they can work on. On the other hand, design is so vast, and we're looking at a truss design problem, and I don't think Jessica's really interested in having people prototype trusses for the next year. So I think there's also, a lot of aspects of design that we're all looking at, and it's still somewhat early. So I think to try to canonicalize the problems would be a little difficult as well.
I'd also say that I think, this pandemic, while pretty horrible, has presented a lot of interesting opportunities for sharing methods online and for, really getting creative with how you are kind of letting the community know about your experimental methods and design. And I think it would be great to see more of us kind of leverage a lot of the online tools that have emerged out of this.
Yeah, so I'm actually going to recommend this. If anyone has any websites or web tools for sharing content that they've created, I'll post one of ours. And I say ours, it's Mark Fuge, mine, and Faez's in the chat window here too. If you have any windows or any websites or things that you've shared content, I encourage you all to post it in there. Okay, this question came in a variety of different ways, and we began to kind of see it towards the end. So people have different views on how they study a team. How do you handle interpersonal differences in teams? And so I think Jess kind of asked that question. John, a question came for you in there, the impact of personality of the member whose designs gets worked with. So we know, I always say there's no I in team, but there are I's in innovation. So you're working in a team. So how do you factor in the individual when you're exploring those things? Kosa, I'm going to send it over to you. You just recently unmuted, so I'm going to send it over to you first.
I thought about staying muted, but this is, no, I think it's a great question. So right now, I think it depends on the problem and the task that you're looking at. So one approach that we're taking is, the study I presented today, we are really concerned with team level outcomes. We're basically engaged in a similar process now, but we're also, in addition to the team level outcomes, tracking those decision-making frameworks of individuals and in coordination with the team. So I think one way that you can get at this is kind of simultaneously tracking individual processes, decision-making factors, or task contributions, as well as, how is the team as a whole performing at these different milestones or checkpoints that are relevant to the given task.
John, I'm going to pass it to you next because it got directed at you in the chat earlier too.
Yeah, no, I think it's certainly a great question, and we're actually looking in other work at personality. But I think one of the other things that I think is that if you're going to really do team science, then you want to isolate variables, and you can't look at everything. So maybe that was intended, or maybe it was a byproduct of the approach we took. But we purposely are not looking at personality, for example, what we showed, because the only way you can exchange information is through this interface, in particular with the actual designs. Now, other work we're doing something similar, but you can talk to each other. And the question is, does personality start to show there? And then, of course, we all know that personality does matter when people get together. We've seen this in our, I've seen this when I'm teaching, working with people in companies as well. So certainly that's got to be something we look at. But I think we also want to be careful that we only look at certain phenomena and can be rigorous about that per study.
And I think something I'll add to it too is John, I think you characterized that well. It's you know what you're studying, you know what you're not studying, and what factors might influence that. So when people are together, you want to make sure that you can replicate the study design, whether it's randomly formed teams and what are the characteristics of those teams, or what are you using to control for in the formation of them. So I think part of it is just identifying in your methodology how those teams were created and what the goals of your study were, so that other people could replicate them too. And that also affects the generalizability of the findings as well. Okay, so I have another question here for Faez from URM. Did you look at the work of Doug Wild from Stanford, which he summarized in his book Teamology, the construction of an organization of effective teams? Is this relevant to your work? So you answered this in the chat earlier, but I wanted to give you a chance to expand on that as well.
Yeah, and yeah, so the short answer is yes, we did look at it, and the work has been a great influence for our work. The main thing which when we started looking into this literature was that we purposefully focused more on generalizable methods which do not look at individual attributes. So it is possible, for example, in the teamology work, there are certain recommendations about what teams work better, but what we did was focused on, we come up with an algorithm which can work in a setting where, let's say, in a particular research, it is found that gender balanced teams perform the best, then yes, you can use this algorithm. But in another setting, if it is expertise balanced teams which work best, then you can use the algorithm for that purpose. So it was a great motivation to develop these algorithms in the way we did.
Great, thank you. This one's for anyone again. So how do you define proficiency in a team or at the individual level of each team member? So how we're talking about like the outcomes of the team, and how do you decide on what you're kind of studying in terms of those outcomes?
Yeah, I don't know. I didn't hear who you wanted to send that to.
Let's start with Jess, because she made a face when I asked the question.
Really, I need to stop being so expressive on Zoom calls. So I made a face because I think it's actually really challenging to leverage metrics. I know, a lot of the prior work within prototyping, for example, has really done a lot of very technical kind of successful or not successful, yes or no, kind of binary metrics to evaluate the technical goodness of a design. And I think that can really leave a lot to be answered or wanted still, right? Because you're not necessarily getting to know the innovativeness or creativity of those designs. I think what helps is obviously having like a very clear or explicit design outcome that is needed. So some sort of a design need or design goal. And evaluating the team's progress towards that goal is obviously helpful. But again, a lot of times it's really challenging to evaluate the effectiveness of an individual or the effectiveness of the team on the whole in situ, right? In the middle of the design process. I think one of the bigger challenges for the field is how do we do this in real time? Because we often don't know how effective they were until the team is either wildly successful or has tailspinned into a burning heap, right? So it's very challenging, I think, in real time, and that's something I'm personally interested in figuring out how to do is how do we track this?
And Faez, I'm going to send it over to you next, because your study looked at it from a very different perspective, where it was people working towards a common goal, but they're working on their own. So how do you define proficiency in that setting?
So yeah, for the experimental task we used an NLP-based expertise matching. So we used a machine learning approach in our experiments where we look at, for example, paper reviewer, we look at an abstract and we look at what you have done and we see how good a match you are. And similar methods are being used for paper allocation in computer science conferences. So yeah, again, that's an assumption that you are a good match if you have done similar papers. But again, I think that in itself is a research question which requires a lot of analysis on what is the right method of studying expertise or even evaluating expertise without the person actually performing the task. And we specifically worked on teams where people were working individually, for example, like reviewers as well as individual ideation tasks. But the method in itself, there was some work which we did where people worked together and they even communicated on a chat platform online. So the method does not restrict for us one type of task versus other. It was just that we chose one. It was easier to run experiments.
Awesome, thank you both. Okay, so Wei Chen put a question in the chat here. First off, John, thank you for thinking Wei, because I forgot to do that at the beginning, and she is the minds behind this whole webinar series. So thank you, Wei, and again to Amy for setting this up. She asked, regarding assessing the performance and outcome of teamwork, it is my understanding that there is rich literature and design research on how to assess the quality or innovative aspects and other effectiveness of design. Can those products or processes related metrics be utilized in teams research? And if not, what is the reason? So John, let me send that over to you first, and then Kosa, I'll send it to you second.
Yeah, well, it's a great question. And on one hand, the answer is, of course, yes. On the other hand, there are people that challenge some of the literature. But even if we say the literature, is a valid way to assess things like, innovativeness, et cetera, and quality, if you're going to do this, real time, you have to be able to evaluate them. So if I have a bunch of designs and I need to go and get a bunch of, several raters to rate them, am I going to be able to do that in real time? No. Am I going to be able to take snapshots throughout? Sure, but every time I take a snapshot, that's that much more work that these raters have to do, and we have to make sure we have consistency. So, early on in a lot of the teamwork research that I started with, we were doing it that way, and I think it's still a very valid way to go, and we still, at times, especially with open-ended problems, have to do that. Part of what Ken Kotowski and I spend time thinking about, though, is can we start to track things real time as they're happening and as we start having effects, in which case then we had to somewhat constrain the type of problem that we could create evaluation functions. So that's why, for the trust is a great example, and I've been doing some work with Chris with drones, and we've looked at other types where drones are complicated, but we were able to assess them as they happen, and we do things in real time. So either you need to be able to have some evaluations you can computationally assess, or you're going to have some way to get those evaluations. So these are very much legitimate metrics, but the question starts to become, when do you take these snapshots? How often do you need to have the evaluations, and how much data do you have?
Great. And yeah, just to add on to that, I agree a lot of, with what John just said, and it really comes back to the type of tasks that we're looking at. So obviously the ideal scenario is we have these tasks that, have these clear measures that we can capture for quality, but that's not always the case. So to me, this also relates to the question of what is a team. And one way we think of what is a team is a collection of decision makers that have a shared or common goal. So a lot of the time for these tasks that have more of a subjective kind of performance measure, we're looking at how well aligned are the team, the individual members of that team, and the way that they're conceptualizing or imagining the goal as the problem evolves. So of course, as John said, the ideal scenario is we have these tasks with these clear measures that we can implement to capture performance. If that's not the case, I might suggest how well aligned are individuals in the way that they're imagining the goal of the team.
Great. Jess, did you want to quickly respond to? I see you just posted in the chat.
I was just also adding to say that, a lot of times if you're really in the middle of the design process, design teams don't really work in the lockstep function, right? It's just this very continuous, chaotic function. So it's difficult to have them stop, hand you a complete design artifact that you can fully leverage a lot of these metrics to evaluate, right? They're often, half-done sketches or half-done prototypes, or, one sentence on a wall. And so it's not necessarily a full picture of the design. It makes it very challenging to really kind of evaluate them using these traditional metrics.
Great. We're going to do a speed round, and then I posted in the chat there the gather.com networking event where we can follow up in there and dive deeper with the authors and with each other, just catching up. I'm going to give you guys 30 seconds to say either a challenge or a word of advice for publishing Teams research in the engineering design community. I am going to send it to John, and we'll go clockwise. So I'll go John, Jessica, Faez, and Kosa, and I mean clockwise on my screen. I don't know how you guys are oriented on each other. So John, do you want to kick that off? You got 30 seconds.
Wait, is the question, do I want to kick it off, or are you saying you want me to kick it off?
It was more of a rhetorical question.
I see, okay.
Yeah.
Yeah, I mean, I think that as we know, teams are prevalent in engineering design. Some of the work that we've also seen is something called the nominal team, where depending on the problem, if you have a bunch of engineers solving the problem themselves alone and pick the best solution, they actually perform in some cases much better than the team collaboratively doing so. Whereas when does that happen? Well, certainly if it's a homogeneous problem and a homogeneous team and a problem that doesn't necessarily have to be decomposed, but that's a big challenge, is when do you really need a team? And then how do you really, as you pointed out, how do you have enough data? How do you have enough understanding of the nuances? Because there's many different variables that come in or are coupled, and you can only study so much at one time. So I think together, these are the challenges, or some of the challenges. They're not all the challenges.
So I'll go next. I think this isn't necessarily a challenge. I think it's just something I'm very excited to see happen. So I guess maybe a challenge with design teams research is, I think more and more we're getting to a place where we're really starting to unpack the individual behaviors of the designer and start to very much understand kind of these micro decision making that's occurring, these micro cognitive processes. And I think what's going to be exciting is when we can start linking those cognitive processes, those micro decisions, to larger level team outcomes, and then ultimately to larger level firm outcomes, to start to kind of in real time be able to track how an individual and also how a team are really contributing overall to firm performance.
Right. So the aspect I would think about is that with this new COVID-19 situation, a lot of us are working online, and I think more and more engineering design community is thinking about virtual teams where people are working from home, and how do they, a lot of research which we have done on how teams work, how does that translate to people working online virtually? And that also brings in the problem of scalability, that now with online teams, you can have thousands of people working together theoretically again in different teams. So how do we manage that? And going back to the main topic of the talk, I would say whenever we are forming teams, diversity is quite important, but just understanding diversity and how do we bring that into the picture for different groups. That's something the community should think about, and I'm happy to chat in the gather.town platform.
Wonderful. Yeah, I mean, it was such an exciting event today, and so many wonderful issues came up, right? We talked about issues of scale and reproducibility, among others. And to me, I think one major challenge or an opportunity facing our community as we move forward is really how we combine computational and qualitative techniques to study teams. So we all brought up this issue of, the teams are hard to kind of like measure their performance, but also we struggled to, I think, gather enough data and how we reproduce that. So I think there's an opportunity here to, combine these techniques, but ultimately, for me, there's this human element of the collaboration and the way that teams work that's so interesting. So I hope that we still maintain this focus on the human designers and the way that they contribute to the team expertise and performance.
Well, thank you all. This has been a fantastic event. Please join me in reacting to our speakers with a round of applause. You guys can just hear it in your minds. You'll have to imagine that. I posted in the chat a link to the gather.com event, and I encourage everyone to participate and get a moment to catch up and kind of continue these conversations. So thank you to ASME for helping host this event, again to Wei and Amy, Dan McAdams, who helped co-host this, and I look forward to seeing everyone over on gather.com. So thanks.
Thank you.